Predictive Aging, the shocking truth about longevity science and reversing time. Hi, I'm Jamie Briggs. Close your eyes and picture a world where age truly is just a number, a place where growing older doesn't mean slowing down, and the years ahead are filled with vitality and adventure. Sounds like science fiction, doesn't it? But what if I told you that this future is closer than you think? Welcome to the inaugural episode of the Longevity.Pink podcast, brought to you by Longevity.Pink. I'm your host, Jamie Briggs, and I'm thrilled to embark on this journey with you. In this series, we'll dive deep into the groundbreaking advancements reshaping our understanding of aging and longevity. Whether you're just dipping your toes into this fascinating field or you've been following it closely for years, today's episode promises to challenge your perceptions and ignite your curiosity. You might be wondering, why all this focus on aging? Isn't it just a natural part of life? Absolutely. Aging is natural, but the decline in health that often accompanies it doesn't have to be inevitable. As we grow older, many of us face chronic diseases, decreased mobility, and a diminished quality of life. But what if we could change that narrative? Imagine adding not just more years to your life, but more life to your years. Longevity research isn't just about extending lifespan, it's about enhancing health span, the period during which we live in optimal health. Scientific advancements are beginning to uncover ways we might slow down, halt, or even reverse the aging process at its core. It's not a question of if we can achieve radical lifespan extension, but rather how we'll integrate these breakthroughs into society so that everyone has the opportunity to benefit. Here at Longevity.Pink, our mission is simple yet profound: to make cutting-edge longevity research accessible to everyone. We're passionate about bringing you expert analysis, in-depth resources, and the latest insights into how science is pushing the boundaries of what's possible. Together, we'll explore the discoveries that are not just extending life, but enriching it. In today's episode, we're setting the stage for a thrilling exploration into the world of longevity and aging reversal. Here's a glimpse of what we'll cover: the latest breakthroughs in longevity science and what they mean for you and me, the intriguing roles of Rapamycin and Everolimus in extending lifespan, including the debate surrounding their use, the revolutionary potential of the Yamanaka Factors in reprogramming our cells to a younger state, Dr. David Sinclair's pioneering research, including his groundbreaking work in reversing aging in monkeys, the societal and ethical implications of extended human lifespans, who gets to live longer, and what does that mean for our world, debunking common myths and misconceptions about longevity research, and a curious look at some of Elon Musk's recent cryptic tweets. Could they hint at secrets in longevity science? But before we dive in, let me introduce you to some of the key figures who are lighting the way in this field. Dr. David Sinclair, a Harvard Medical School professor, changing how we think about genetics and aging. Dr. Shinya Yamanaka, the Nobel Prize-winning scientist behind the discovery of the Yamanaka Factors. Dr. Nir Barzilai, leading the charge in clinical trials exploring metformin as a potential longevity drug. Dr. Aubrey de Grey, a visionary advocating for strategies to reverse aging damage. Their stories, their discoveries, and their passion will be threads we weave through our conversation today. Let's start by painting a picture of where we are right now. For years, aging was seen as an unstoppable force, a one-way ticket toward decline. But recent scientific breakthroughs are flipping that script. Researchers are now viewing aging not as an unavoidable destiny, but as a biological process that can be understood, influenced, and potentially reversed. Take, for example, the study of cellular senescence, where cells lose their ability to divide and function. Scientists have discovered ways to clear out these zombie cells, potentially rejuvenating tissues and organs. There's also exciting work happening with telomeres, the protective caps on our DNA that shorten as we age. By preserving or even extending these caps, we might keep our cells healthier for longer. This is all measured using the epigenetic measure of methylation, which represents the overall age of an organism, considering all factors. So what's behind the aging curtain? Well, it's a complex interplay of genetics, environmental factors, and lifestyle choices. At the cellular level, several key players contribute to the aging process. Genetic and epigenetic changes. Over time, our DNA accumulates damage, and the way our genes are expressed can change. Telomere shortening. Each time a cell divides, these protective DNA caps get a little shorter, eventually leading to cell aging. Mitochondrial dysfunction. The powerhouses of our cells can become less efficient, leading to decreased energy and increased oxidative stress. Cellular senescence. Cells that stop dividing can release harmful substances that affect neighboring cells. Protein accumulation. Damaged or misfolded proteins can build up, disrupting cellular function. By targeting these mechanisms, scientists are crafting strategies to not just slow down aging, but potentially reverse its effects. This isn't just happening in a lab somewhere, real-world applications are on the horizon. Exciting clinical trials are underway. Rapamycin studies, exploring how this drug affects immune function and longevity. The TAME trial, investigating metmorphin's potential to slow biological aging. Cellular reprogramming research, testing the safety and efficacy of using Yamanaka factors in humans. Stem cell therapies, looking into regenerating aging tissues and organs by introducing more stem cells. Young blood transfusions. Modern-day vampires receive blood from younger people intravenously, which supposedly helps them stay younger for longer. These studies bring us closer to a future where age-related decline isn't a given but a choice we can influence. Let's delve into the fascinating world of rapamycin and its derivative Everolimus. Discovered in the unlikeliest of places, Easter Island, rapamycin began its journey as an antifungal agent, but scientists soon realized it had potent immunosuppressive and anti-proliferative properties, leading to its use in organ transplantation and cancer treatment. At the heart of their magic is the inhibition of the mTOR pathway, a critical regulator of cell growth, metabolism, and aging. mTOR is a sort of cellular accelerator pedal. Inhibiting mTOR is like easing off the gas, allowing the body to engage in maintenance and repair processes like autophagy, where cells clean out damaged components. But it's not all smooth sailing. While these drugs have extended lifespan in various animal studies, Everolimus showing up to a staggering 440% increase in mice, they come with challenges. Side effects like impaired wound healing and immune suppression are significant concerns. Moreover, accessibility is a major issue, with Everolimus costing up to $30,000 per month when prescribed for certain medical conditions. Consider the story of Brian Johnson, a biohacker and self-proclaimed lab rat who is fascinated with the idea of living as long as possible. As part of his extensive longevity regimen, he became interested in rapamycin's potential. Under careful medical supervision in the micronation of Roatan, he has documented his journey with life extension, sharing his experiences on platforms like YouTube. However, contrary to many studies suggesting positive effects, Brian noticed changes he perceived as negative while taking rapamycin, including concerns that it might be accelerating certain aspects of aging in his body. As a result, he decided to stop using the drug. His experience highlights the promise and peril of self-experimentation in the quest for longevity, emphasizing that individual responses to such treatments can vary widely. Yamanaka Factors, rewinding the cellular clock. Meet Dr. Shinya Yamanaka. In 2012, Dr. Shinya Yamanaka rocked the scientific world by discovering that mature cells could be reprogrammed back into pluripotent stem cells using just 4 transcription factors: OCT4, SOX2, KLF4, and c-MYC, now famously known as the Yamanaka Factors. Imagine if your cells had a reset button. That's essentially what the Yamanaka Factors provide. By reintroducing these factors, scientists have been able to erase signs of aging in cells, effectively resetting their biological age. But here's the catch: fully reprogramming cells can erase their identity, leading to risks like tumor formation. The challenge is applying partial reprogramming, rejuvenating cells just enough to restore function without losing their specialized roles. Biotech companies and research institutions are racing to harness this potential. If successful, therapies based on the Yamanaka Factors could revolutionize how we treat age-related diseases, ushering in a new era of regenerative medicine. David Sinclair's quest to reverse aging, a visionary in the field. Dr. David Sinclair, a genetics professor at Harvard Medical School, has become a leading voice in aging research. He's on a mission to tackle aging head-on, viewing it not as an inevitability, but as a condition that can be treated. Sinclair's research focuses on epigenetics, the study of changes in gene expression that don't involve alterations to the underlying DNA sequence. He's particularly interested in how molecules like NAD+ decline with age, affecting vital processes like DNA repair and energy metabolism. In a groundbreaking study, Sinclair's team applied a technique based on the Yamanaka Factors, using 3 of them known as OSK, OCT4, SOX2 and KLF4 to older monkeys. The results were astonishing. Not only did they restore the monkey's vision, but they also reversed the epigenetic age of the monkey when administered generally throughout the body. Sinclair explained on Neil deGrasse Tyson's Star Talk podcast. When we turn these genes on again in adult animals, whether it be a mouse or a monkey, they rejuvenate, their tissues heal, and they get young again. The success of this experiment opens the door to possibilities once reserved for science fiction. Treating age-related blindness, restoring sight to those who've lost it due to aging, combating neurodegenerative diseases, rejuvenating brain cells to fight conditions like Alzheimer's and Parkinson's, organ regeneration, healing the heart, liver and other organs that deteriorate with age, extending health span, enhancing overall vitality and reducing age-related frailty. But it's not without controversy. Skeptics question the long-term safety and potential unintended consequences, emphasizing the need for cautious optimism. The bigger picture, policy and population implications. A new age for society. As we stand on the cusp of a longevity revolution, we must consider how extended lifespans will reshape society. Longer, healthier lives could lead to economic growth, a more experienced workforce contributing for longer periods, redefined retirement, shifting perceptions of retirement age and career trajectories, healthcare evolution, moving from reactive treatments to preventative longevity-focused care. Yet, with great power comes great responsibility. Ethical dilemmas loom large. Access and equality. Will these treatments be available to all or only to a privileged few? Overpopulation concerns. How will a larger, older population impact resources and the environment? Social dynamics. What happens to societal structures when lifespans extend significantly? Avoiding a dystopian future. A haunting question arises, could humanity be divided into the long-lived elite and the mortal masses? To prevent such a scenario, proactive policies must ensure equitable access to longevity treatments. Consider the words of bioethicist Dr. Jane Wilson. We have an unprecedented opportunity to enhance human well-being, but it must be vigilant to avoid exacerbating societal inequalities. Longevity should be a shared blessing, not a divisive force. It's natural to worry that extended lifespans might lead to overcrowding. However, studies suggest that declining birth rates in many parts of the world may offset increases in lifespan. Additionally, advancements in sustainability and resource management could mitigate these concerns. Another misconception is that longer life equals prolonged frailty. The goal of longevity research is the opposite, to enhance vitality and reduce the incidence of age-related diseases, ensuring that extra years are healthy ones. Will we have to work forever? Not necessarily. Extended health spans could lead to more flexible careers, lifelong learning, and opportunities to explore multiple passions over a lifetime. Playing God. Ethical considerations are paramount. Is reversing aging unnatural, or is it an extension of humanity's long-standing pursuit to heal and improve the human condition? By alleviating suffering and enhancing quality of life, longevity science aligns with the core objectives of medicine. Elon Musk's cryptic clues. Recently, Elon Musk tweeted about over 1 million individuals over 150 years old appearing in Social Security records, a claim that stirred both intrigue and skepticism. While likely a quirk in data, it sparks the imagination. Could there be secrets in longevity science still to be unveiled? Musk's musings, coupled with rapid advancements in the field, remind us that the boundary between science fiction and reality is ever shifting. As we navigate this exciting frontier, one thing is clear. The quest to understand and influence aging is not just about extending life, but enriching it. The possibilities are as vast as they are profound. So, what's on your mind? How does the prospect of longer, healthier lives make you feel? Imagine celebrating your 100th birthday by embarking on a new career, traveling the world, or learning a new art form. We want to hear from you. Share your thoughts, questions, or ideas for future episodes. Reach out to us on our website or join the conversation on X, formerly Twitter, @Longevity.Pink. Remember, this isn't just about scientists in labs, it's about all of us. Together we can shape the future of aging, ensuring that the benefits of these incredible advancements are shared widely and wisely. Stay curious and stay young at heart. Thank you for joining me on this inaugural episode of the Longevity.Pink podcast. Until next time, keep dreaming big and questioning the limits of what's possible.